When people first encounter a magnet, it feels almost disappointingly simple. You bring it close to a piece of metal, and the metal moves. No visible contact, no pushing, no pulling that you can see, just motion, as if something invisible reached across space and decided to act. Most of us accept this before we ever question it. It becomes one of those background facts of reality, like gravity or sunlight. It just is. But the moment someone asks a very direct question, why does it do that? Everything changes. At first, the answers seem satisfying. We talk about magnetic fields. We draw lines around the magnet, neat curves showing how the force spreads through space. We explain attraction and repulsion. We describe electrons moving, charges interacting, atoms aligning. Each explanation sounds deeper than the last, more technical, more precise. It feels like progress. Yet if you keep asking the same simple question, why does any of that happen at all? Something strange occurs. The explanations start looping back on themselves. A magnetic field causes a force, but what is a field, really? A property of space. Fine. But why does space have that property? Because of electric charge and motion. And why do charges create fields? Because that's how nature behaves. At some point, every explanation quietly turns into description, and that is the moment where everyday logic begins to break down. In ordinary life, we expect causes to resemble effects. If something moves, something must push it. If something changes, something must touch it. Our intuition is built from physical contact, hands, tools, collisions. But magnetism refuses to obey that psychological expectation. It operates through empty space, no strings, no gears, no visible mechanism bridging the gap. This is deeply unsettling to the human mind, even if we don't consciously notice it. We are comfortable with what we can picture. We are comfortable with what we can imagine happening step by step. But magnetism is not obligated to fit inside human imagination. It does not need to resemble anything familiar. It simply operates according to the structure of reality itself. And here is the deeper twist. What most people call understanding is often just the ability to tell a story that feels comfortable. We replace mystery with metaphor. We say fields are like stretched rubber sheets, or invisible winds, or flowing energy. But these are mental props, not reality. They help us cope with the strange, not eliminate it. So when you ask why magnets work, you are not really asking about metal or force or motion. You are asking whether the universe must make sense in the way human minds prefer. You are asking whether explanation must eventually arrive at something familiar, or whether reality can simply be fundamentally, irreducibly what it is. And that is where the simple magnet becomes something profound. It exposes the boundary between description and true explanation. It reveals that some parts of reality may not be hidden from us. They may simply be basic, needing no deeper reason beyond their existence. And perhaps that is the real discomfort, not that we don't know enough, but that reality might not owe us a reason at all. So the next time you see a magnet, pull something toward it. Don't just notice the motion. Notice the mystery that remains even after every explanation is finished, because understanding begins the moment we admit where explanation ends. Think for a moment about the way our minds are built. Evolution didn't equip us to understand magnetic fields or quantum spins. It didn't train us to intuit forces that act across empty space, or particles that behave like waves and waves that behave like particles. Our brains evolved to survive on the African savanna, to notice predators, find food, read faces, and predict movement in the macroscopic world. That's what we are good at. That's what makes life understandable day to day. But magnetism doesn't care about survival. It doesn't fit neatly into the categories our senses and intuition were designed to handle. That's why, even after centuries of study, it continues to surprise us, to feel almost unnatural. When you try to picture a magnet's influence, your mind struggles. You imagine invisible lines, fields curving through the air. You think about atomic spins aligning like tiny compass needles. But as soon as you try to truly see it, to grasp it the way you grasp a thrown ball or a rolling stone, the images break down. The mind instinctively wants to trace contact, to follow chains of cause and effect. But the world of magnetic interactions doesn't follow that pattern. Electrons interact in ways that are counterintuitive, obeying rules of quantum mechanics that make no sense in the language of everyday life. Probability waves, uncertainty, the idea that a particle can be in two places at once. These are not just abstract concepts. They are the operating instructions of the universe, and they are fundamentally alien to our perceptions. This is the psychological barrier. We are tempted to say we understand something when we can picture it, and when something defies our ability to picture it, we often invent stories, mental props, to make it palatable. We call them metaphors, magnetic lines like rubber bands stretching through space, or invisible winds pulling iron toward the pole. They comfort us and they help us communicate with one another, but they are not reality. Reality does not bend to our comfort. It simply is, and we must confront it on its own terms. There is a profound lesson here. True understanding is not measured by how easily a phenomenon fits into our intuition. It is measured by our willingness to let go of that expectation, to accept that our brains, clever as they are adapted to a narrow slice of existence. Magnetism exposes the limits of human intuition not as a failure, but as an opportunity. It forces us to confront a universe that is more intricate, more subtle, and more extraordinary than our everyday experience suggests. So when you hold a magnet or watch it attract a nail across a table, remember that what is happening is both simple and unfathomable. Simple in that it follows the laws of physics, unfathomable in that those laws operate on scales and in ways that challenge the very framework your mind evolved to rely upon. And in that tension, in the space between familiarity and mystery, lies the true adventure of discovery. The universe will always be stranger than we imagine, and it is only by embracing that strangeness that we begin to see the world as it really is. Next time you witness the pull of a magnet, let it remind you not only of the forces at work in matter, but of the humility required to engage with a reality that refuses to conform to human expectation. That tension, that discomfort, is where learning begins, and where curiosity becomes courage. Science is remarkable in the way it takes the invisible and makes it predictable. It gives us tools to describe the world with astonishing precision, to capture behaviors that once seemed magical and turn them into equations, models, and experiments. A magnet, for instance, is no longer a mysterious object of whimsy. We can measure its fields, calculate the forces it exerts, even predict exactly how it will influence other magnets or metals. Maxwell's equations tell us how electric and magnetic fields relate. Quantum mechanics explains how electrons spin and align to create the phenomenon we call magnetism. In terms of utility, in terms of practical understanding, science has triumphed. But here is the subtle distinction that most people miss. Description is not the same as explanation. Science can tell you how magnets behave in exhaustive detail, what directions they point, how strong the pull will be, what happens at the atomic level, and yet it does not necessarily answer why the universe allows this behavior at all. We can understand the rules, but the rules themselves remain, in a sense, mysterious. Why do electrons have spin? Why do fields exist at all? Science can model these things with remarkable fidelity, but it stops short of providing an ultimate reason for their existence. There is a boundary between description and explanation, and magnets sit right at the edge of that boundary. This boundary is where philosophical reflection meets scientific rigor. We tend to assume that if something is described, it must also be explained. But physics teaches us that understanding the universe is often about constructing models that predict reality, not necessarily uncovering some hidden cause behind the cause. The laws of physics do not have to make intuitive sense. They do not have to be grounded in human experience. They are statements about patterns, about consistency, about relationships that exist independently of our perception. Magnetism is one of the clearest illustrations of this principle. It obeys rules with absolute fidelity, yet the rules themselves resist any deeper reason we can articulate, and this is not a limitation of human intelligence. It is a feature of reality. We must distinguish between knowledge that allows mastery and knowledge that provides existential clarity. We can harness magnetic forces to generate electricity, to store data, to power trains, all with perfect precision, and still wonder, at the deepest level, why these forces exist in the first place. The ability to describe and the desire to explain are distinct, and magnetism forces us to confront that distinction directly. So when you next think about a simple bar magnet, remember that scientific models you rely on, Maxwell's equations, quantum theory, atomic spin, are tools of unparalleled power, yet they are ultimately descriptive. They allow us to predict and control, but they do not demand that reality make intuitive sense. And in that distinction lies a profound lesson. The universe can be understood, but not always explained in terms that satisfy human curiosity. Accepting that boundary is not defeat, it is insight. It reminds us that the pursuit of knowledge is not about eliminating mystery, but about learning to navigate it, to find clarity where we can, and humility where we must. The universe grants us understanding, but it reserves explanation. And that is precisely what makes the study of nature, and of something as seemingly simple as a magnet, endlessly beautiful. When Richard Feynman famously said that he could not explain why magnets work, he was not admitting ignorance. On the contrary, he understood more about the universe than almost anyone, yet he recognized a boundary that most people are unwilling to face. Some questions simply do not have answers in the way we expect. We are used to explanations that satisfy our desire for stories, for causes and effects that fit neatly into the framework of human experience. But the universe does not owe us a story, nor does it need to behave according to our mental expectations. Feynman's refusal was an act of intellectual honesty, a quiet acknowledgement that reality can be more subtle than language can capture. This idea is humbling, but it is also liberating. It forces us to confront a truth that many shy away from. The universe may operate according to principles that are irreducible, fundamental, and beyond our capacity to imagine fully. Magnetic forces, quantum spins, the interactions of electrons and fields. These are all phenomena we can observe, predict, and manipulate. Yet when it comes to asking why they exist at all, we reach a limit. That limit is not a failure of science. It is a feature of reality itself. It is a reminder that human knowledge is both powerful and provisional, able to describe patterns and control outcomes, yet not always able to uncover ultimate reasons. There is also a psychological lesson here. We often feel uncomfortable with the unknown, as if admitting mystery is admitting weakness. But embracing uncertainty is a mark of intellectual courage. When Feynman refused to give a simple answer about magnets, he was not avoiding explanation. He was showing that true understanding sometimes requires recognizing the limits of our own cognition. Accepting that some truths may be inherently mysterious does not diminish science, it enriches it. It encourages a mindset of curiosity, humility, and open-minded exploration, rather than clinging to comforting but ultimately incomplete narratives. This boundary between what can be described and what can be explained teaches us something profound about the nature of inquiry itself. It reminds us that our role as thinkers is not to force reality into the boxes of our imagination, but to follow the evidence wherever it leads, even if it leads to places that feel strange or uncomfortable. Magnets, in their silent, invisible work, embody this tension. They are at once ordinary and extraordinary, comprehensible and mysterious, predictable and fundamentally inexplicable. They invite us to reflect not just on the nature of matter, but on the nature of understanding itself. And so the lesson Feynman leaves us is not about magnets alone. It is about the attitude we take toward all knowledge. The universe will present itself to us honestly, if we are willing to observe, measure, and think deeply. But it will not provide explanations that satisfy every craving of the human mind. Our task is to engage with reality faithfully, to explore its patterns, and to remain humble before its mysteries. In the end, the refusal to explain is not denial. It is an invitation. It is an invitation to think more clearly, to question more boldly, and to embrace the wonder of a universe that is infinitely richer than any simple answer could capture. If you carry that lesson forward, you will see the world not as a set of solved puzzles, but as an endless landscape of discovery, waiting for curiosity, courage, and imagination to roam freely.